Welcome everybody! In this video, our group will share our insights from our recent visit to Indorama Polyester Industries in Nakhon Pathom. During our visit, we were introduced to Indorama's process of producing recycled polyesters, re-PET. Recycling plastic is a key factor when battling environmental issues. It also has a great economic potential as big brands like Coca-Cola are increasingly showing interest in using recycled materials in their products. In this presentation, we will discuss these following topics.
First, let me begin by introducing you to a key part of company. Indorama Polyester Industry site in Nakhon Pathom was acquired by Indorama Venture in 1998 from Siam Polyester and renamed Indopoly Thailand Limited. In 2009, it merged with Indorama Polyester Industry Public Company Limited. Since 2013, with a strong focus on sustainability, significant investments have been made in post-consumer waste recycling operations at this site. Today, it stands as the only IVL site that produces both virgin and recycled polyester. The second part is product overview. The site has production facilities for polyester resin, virgin polyester, staple fiber, recycled polyester staple fiber, post-consumer recycled PET flakes or PET flakes, and recycled PET resins or PET resins. The site also has a bed polymerization facility to produce specialty polyester resins. The next topic is constraints between demand and supply. Demand for our products is growing, but there are some challenges in meeting it. These challenges include limited production, supply chain issues, and resource availability. However, our company is working hard to overcome this and ensure we can continue to meet consumer needs.
Resolved issue is when an elderly delivery driver at the age of 16 failed to follow safety protocols, acted recklessly and died in an accident. An incident is the driver fell off his truck while removing a trap because of the improperly secured ropes. The accident occurred despite existing safety measures. The solution is additional safety protocols were introduced, including mandatory health checks such as monitoring the driver's blood pressure. Next is ongoing issues, is the dust from the granulator process. So the current action is replacing the zigzag one simulator with a more efficient machine to reduce PET losses and dust. The new system will involve vacuum technology to keep the dust from exiting the process. For problem description, fine dust is generated in the granulator, where flake particles collide with granulator blades at high speed. The buildup of dust increases the risk of explosion and affects workers' health when breathed in. Background of these problems is while no major incidents have occurred in Thailand, there have been accidents at other Indorama sites around the world. Within the Indorama group, issues are shared and discussed openly to prevent future incidents.
The IDEF 0 Level 0 diagram shows 4 primary functions: supply, Indorama plant, logistics, and customers. Each function encompasses a set of tasks that collectively contribute to the overall plant operations. Suppliers are responsible for the collection of used plastic bottles, which are subsequently purchased by the plant. These bottles will be delivered to the factories in agreement with the established delivery schedules and order quantities. After their arrival, the used bottles are subjected to several processes to produce rPET, flakes, and pellets. The resulting product is intensely tested and certified to be safe for food and beverage applications, sticking to the high standards such as ISO and SVHC. Moreover, it undergoes demanding treatment, sorting, and quality control process, and ensuring environmental sustainability.
In IDF 0 Level 1, the focus is on presenting the primary function of the system, which include plan, source, make, deliver, and return, without too much detail. So let's close up in plan. Planning stage are up to MOU and order of customer. The plan should manage capacity, specification, and schedule, without tracking by the employer using spreadsheet before execution. In the source stage, raw material and ingredients are obtained, with strict control over KPIs. Supplier ensure the flow materials and quality check are done by laboratory. Used bottles are sent for processing into rPET in making stage. During the make stage, factors like quality standards, sourcing, safety, and machine operation must be controlled to produce rPET flake and pellets. And when we got out this product, it will be delivered to customers such as Indorama, Rayong, or Arthur, with monitoring ensures smooth operation. Finally, products may be returned by customer if there are issues with specification or quality.
Examination of customer satisfaction. Customer evaluation forms are always provided after product delivery. Based on the feedback received, there have been no complaints. The company consistently delivers product as agreed and on time. The company is committed to maintaining and strengthening long-term relationship with its customer and will continue to ensure customer satisfaction by providing high-quality products and service that meet customer needs. The company serves customers with enthusiasm through open communication, actively listening to feedback, and continuously improving to exceed expectations. Safety and organization. Safety and environment divided into two parts: regulation for visitor and regulation for employee and personnel. Regulation for visitor. Unauthorized persons are prohibited from entering the premise without prior permission. Individuals under the age of 18 are not allowed to enter the area. Eating and drinking are only permitted in the cafeteria. Firearms, intoxicating substances, and hazardous items are strictly prohibited. Wearing flip-flops, high heels, shorts, or jewelry are not allowed. Bags are not permitted inside the factory premises and must be deposited at the front office area. Taking photographs or video inside the factory premises is prohibited. All visitors must comply with the rules and regulations. Waste must be disposed of properly according to waste segregation guidelines. Drive cautiously with the premise with a maximum speed limit of 50 to 20 km per hour. Smoking is prohibited within the factory premises and only allowed in designated smoking area. Visitors must present their national ID or passport to security personnel at the gate before entering. Dress code for factory visitors: wear long sleeve or short sleeve shirt, wear long pants, wear safety shoes, wear safety helmet. Guideline for factory tour: present your ID or passport for verification by security personnel. Wear long sleeve or short sleeve shirt, long pants, safety helmet, and sneakers before entering to factory premises. Use earplug in area with high noise level. Walk within the yellow lines marked on the floor and never step outside them. Do not touch machinery or equipment, as it may result in life-threatening accidents. Smoking is strictly prohibited in the factories. Be cautious of forklifts or other moving equipment. Regulation for employee and personnel. Wear long sleeve or short sleeve shirts and long pants, or wear safety helmets when inside the factory or while working. Wear safety shoes. Wear gloves while performing tasks. Use earplugs in areas with high noise level. Wear face mask while working to prevent dust-related issues. Smoking is prohibited within the factory's permit except in designated smoking areas. Eating is not allowed inside the cafeteria.
Cleanliness. Since this factory focus on recycling, the material are not hygienic and a large amount of waste is generated. However, the waste is systematically handled and stored in an organized manner. The machinery and equipment within the factory are kept clean and daily cleanings and maintenance routine. The factory is well segmented and raw materials are sorted and cleaned thoroughly, resulting in high quality product that beat standard. Summary of safety, cleanliness, and environment. The company enforces an environment, health, and safety policies which apply to all personnel. This policy demonstrates the company's commitment to employees' well-being, customer satisfaction, environmental protection, and community care. Examples of initiatives under this policy include monitoring unsafe actions of factors, empowering employees to halt operations if they feel unsafe, and allowing them to report risks to supervisors at any time. A hazard management system and standard operating procedures are in place to mitigate risk. This policy is integrated into all business management process and must be followed strictly.
Visual management system. This system is a management method that is easy to understand and implement through visual cues. Aim to organize the workplace systematically, ensure a safe and efficient working environment. In the factory, the space is clearly divided into 10 distinct areas. In each area, one can observe various signs that provide announcements, directions, and regulations. These include directional signs, instructional signs, signs indicating the organization of factory space, assembly point signs, and no smoking signs. Additionally, the factory has yellow lines that indicate safe walking zone, which must be adhered to for safety. There are also color-coded signal lights on machinery, enabling employees to understand the machine status and performance correctly. Prohibition and warning signs are displayed to guide and restrict access or operations in certain areas, ensuring safety and enhancing the efficiency for the workforce. The combination of warning signs, signal lights, organized space, and systematic arrangements enable employees to work effectively and safely,
reducing the risk of accidents.
Production scheduling system. The operation uses an average of 125 to 130 tons of bottles per day. The entire process is continuous and takes 1 hour per cycle, with each production line capable to conducting 2.4 tons per hour. Analysis of space utilization. The factory is divided into 10 clearly defined areas, making it easy to understand and ensuring that each area is optimally designed for its purpose. Gate 1 and Gate 2. Gate 1. A guard post where ID card or passport are exchanged for visitor card. Front office area. A place for storing bag, luggage, and for visitors to interact with staff. Utility Area 1. A general purpose utility area. Utility Area 2. Another general purpose utility area. Polymerization area. This area handles batch and continuous resin production, where polymers are delivered to the fiber department for the production of polyester fiber. In subsequent process, the products are also available for market sale. Fiber area. The area for producing staple fiber including both virgin and recycled root. Warehouse. Store space primarily for finished product, organized according to store requirement. Coal-fired area. A heating area where a coal-fired heater is used to generate process steam. Recycle plant. In this area, post-consumer recycled bottles are shared into flakes and further processed into rPET chips. Assembly areas. To design area for assembly operation. Material flow refers how two materials move through a system, showing the path of raw material component, combined substance, and final products. It will start with receiving raw materials, go to production, and ends with sorting finished goods. One important and complicated part of this process is water treatment. The factory clean or treat water during the process. Both material and waste are products including wastewater discomfort, label removing, wet granulation, drying and paper sorting, dye granulation, stored, silo, flake feeding, dust and smoke. These are also created during the sample step, but there is currently no proper way to treat them. Other waste. These include waste from pre-sorting and material detection, and plastic, metal, color sorting, which is usually sold to manage it.
Material flow analysis. Material flow refers to how materials move through a system, showing the path of raw materials, components, combined substances, and final products. It starts with receiving raw materials, goes through production, and ends with storing finished goods. One important and complicated part of this process is water treatment. The factory cleans and reuses treated water. During the process, both materials and waste are produced, including wastewater. This comes from the following: label removing, wet granulation, drying and paper sorting, dry granulation, storage silo, and flake feeding. Dust and smoke. These are also created during the same steps, but there is currently no proper way to treat them. Other waste. This includes waste from pre-sorting and metal detection and plastic, metal and color sorting, which is usually sold to manage it. Inventory management. Inventory levels in a plastic bottle recycling plant for rePET pellets. Covering raw materials. Used PET bottles should be stocked sufficiently to support continuous production, depending on the amount of waste collected. Approximately 350 to 360 tons per day. Work in process. Items like cleaned bottles and shredded plastic should be managed in line with the production process to ensure smooth operations. Production process. The production process for recycling PET requires that plastic bottles be first compressed into bales, which are then brought into the factory. The bottles are inserted into a machine and sorted. Labels are separated from the bottles. Thermal processing is used for cleaning bottles before going through the next step. Any impurities, such as iron, sand, or other types of plastics, are cleaned out. Afterwards, the bottles are crushed into small flakes and cleaned again. PET flakes are now ready to be used. The flakes are examined before they are melted. The flakes are melted at 285 to 300 degrees Celsius to become recycled resins or rPET. Completed product. Virgin polyester, 120 kilotons per annum. Flakes, 32 kilotons per annum. rPET, 24 kilotons per annum. rPSF, 18 kilotons per annum. Polymer pilot plant, 25 kilograms. Finished goods should be stored adequately to meet customer orders, which are sent to preform manufacturing plants and other customer factories.
Motivation among the workforce. The company treats all employees with respect and believes that fair compensation serves as a motivation for employees to continuously contribute to the company's success. Furthermore, it places great importance on developing employees' skills, knowledge, and potential by fostering a positive work environment which motivates and maintains good employee performance. Machine maintenance. The production line is scheduled to shut down for 4 hours daily with the KPI indicating an operation time of 21 hours per day. During the shutdown period, maintenance, cleaning, and minor breakdowns are addressed. The scheduled shutdown time is from 9 a.m. to 12 p.m. to facilitate cleaning processes, such as removing ropes tangled around rollers and sharp objects. The mechanics team is also tasked with replacing the blades of the granulator every day due to the length and demands of the production line. A maintenance schedule is defined to specify what tasks need to be performed each day during the shutdown.
In this section, I will talk about the management of complexity and variability, which I have separated into two main topics. 1. Health, safety, and environmental compliance. 2. Continuous improvement and innovation. Let's first look at the challenge in health, safety, and environmental compliance, and then move on to the complexity of continuous improvement and innovation. Health, safety, and environmental compliance. Complexity. Manufacturing industry, such as the chemical or polymer sectors, must comply with strict regulations regarding safety, environmental standards, and employee health. Variability. Environmental conditions, regulatory updates, or even change in local laws can impact operations. Let's move on to continuous improvement and innovation. Complexity. Keeping up with technological advancement, new product development, and adapting to evolving industry standards can be challenging. Variability. Consumer needs, market trends, and competitor actions can change unexpectedly.
Last one is assessment of quality management related to standards and systems, or include ISO 9001, QMS, ISO 50001, ENMS, ISO 14001, EMS, ISO 45001, Occupation Health and Safety Management System, Global Recycle Standard or GRS, Recycle Clean Standard or RCS, Octec 100, and EcoMark.
Thank you for your listening, and thanks again for Indorama Polyester Industry for your hospitality.
And this is our members
ชนวสาอินหลวง
เตชะพัฒน์ปฐมนิติกุล
ธนาพรประทุมรัฐ
ธันวรัตน์ มหันทสนพงศ์
กรณัฐนิธิวัฒนานันท์
Emilia Uusitalo.